Good afternoons. This chemistry class, chapter 8, covalent bonding. Okay. Next week your exam, first online exam in chemistry will be held. That may on 31st August at 12 p.m. At 31st August at 12 p.m. your first online exam will be held. Topics: bonding. Chapter 7, 8, 9. 7 ionic bonding, 8 covalent bonding, 9 metallic bonding. Okay, next week you have an exam which will be held at 12 p.m. Topics: bonding, chapter 7, 8, 9. Okay, this today's class I am going to start. Welcome to my today's class. Covalent bonding part 2. There are 7 elements that exist as diatomic molecules. 2 atoms covalently bonded together. These 7 elements: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. These are 7 elements exist as diatomic molecules. They are shared pair of electrons, like hydrogen. Share a pair of electrons, so one covalent bond here. So 7 elements that exist diatomic, monoatomic, triatomic. Do you know triatomic molecule? A triatomic molecule is, do you know? Can you give example a triatomic molecule? Example. Triatomic molecule.
Nitrogen.
Hydrogen. Triatomic is ozone. I took these things. Ozone is triatomic. Triatomic is ozone. Yeah. এটা কি ক্লাসিক 2-1 এরকম স্টুডেন্ট আমি ঢুকাইব না তো, নাম ঠিক নাই। এটা নাম ঠিক করে তো বলো, এটার নাম, এটা রিমুভ করে দিই। অ্যাড হয়ে গেছে নাকি? রিমুভ, সে ঝামেলা করিতা। দেখতেছ না এরা রিমুভ করছি? দরকার আছে নাই, দরকার নাই। ডোন্ট রিপোর্ট। তোর আবার এটা কি তাইলো? রিপোর্ট করতাম না রে, আবার রিপোর্ট নাই, যাও। আচ্ছা, দেখছো নাকি তাইছে এখানে? তোমরা দেখো নাই মনে হয় না? এটা হচ্ছে ট্রাইঅ্যাটমিক। এখন একটা স্টুডেন্ট ঢুকতে আসলো, নাম আননোন নেম দিয়া। এটা হচ্ছে ডাইঅ্যাটমিক। এখানে 2টা অ্যাটম জয়েন্ট আছে আর এখানে 3টা অ্যাটম জয়েন্ট আছে, ট্রাইঅ্যাটমিক। আচ্ছা, জানো তো ফসফরাস কি অ্যাটমিক? 4টা অ্যাটম জয়েন্ট থাকে ফসফরাসের মধ্যে, ফসফরাস মলিকুলের মধ্যে। তো আমরা জানলাম। আর নোবেল গ্যাসগুলো সবগুলো কি? অল নোবেল গ্যাসেস আর monoatomic. Helium, neon, argon, krypton, xenon. They are monoatomic. They exist as monoatomic. Okay. So we have understood diatomic, triatomic, monoatomic, tetratomic. This is diatomic molecules. Okay, 2 atoms joins here. Okay, there are 2 types of covalent molecules: giant covalent molecules and molecular covalent. Molecular covalents are number of atoms are fixed, like water number of atom is fixed. 2 atoms oxygen, 2 hydrogen atoms, 1 oxygen atoms. There are 3 atoms. Number of atoms are fixed. And giant covalent molecule, the giant, no fixed number of atoms. Silicon dioxide, here number of atom is not fixed. Giant molecules, yeah, lot of okay. Covalent molecular, just like water. Covalent molecular structure are small. molecules that have fixed number of atoms, for example water or ammonia. Example are fullerenes are diatomic molecules. They are also covalent molecular. Covalent moleculars like fullerenes are allotropies of carbon. Okay, so what is allotropies? Allotropy is the different form of a same element. Same element, different form of a same element is allotropy. Like carbon has different form: graphite, uh, diamond, and fullerene. So these are allotropies of carbon. They okay. This is another allotropies of carbon is fullerenes. They contain 60 or 70 carbon atoms in the shape of footballs. They are discrete molecular solids. Okay, there is atom number is fixed 60 or 70. Okay, diatomic elements are 7 elements that exist as 2 atoms covalently bonded together at room temperature. Okay, intermolecular forces. In molecular structure, the molecular covalent, there are fixed number of atoms joined by strong covalent bonds. In covalent molecular substance, there are also bonds between molecules called intermolecular forces. Okay, there are 2 types bond present in molecular structures. Covalent molecular structure, there are 2 types bond present: strong covalent bonds and intermolecular bonds. Look, this is here water molecule, to 1 hydrogen, 1 oxygen, and two hydrogen atoms joined together by strong covalent bond. This is water molecules, and here another water molecules. Among these water molecules, there is a force, intermolecular attraction force between. Okay, but the intermolecular attraction between the water molecules are weaker. Okay, so which is stronger? Stronger is covalent bond, and intermolecular attraction force among water molecules are weaker. Okay, now giant covalent networks. Carbon exists in 2 different networks from diamond and graphite. This is diamond. In diamond, each carbon atoms form 4 covalent bonds. This is done by sharing each of its 4 outer electrons with 4 other carbon atoms. When this arrangement is extended throughout 3 dimensions, a giant covalent network structure results. So this is diamond is a giant covalent networks. Here we know carbon atoms in the outer shell, there is 4 electrons. All 4 electrons are used for covalent bonding. There is no remaining electrons here. Now this is graphite. In graphite, another example, graphite. Each carbon atoms form 3 covalent bonds. So another electrons remaining. 3 others with 3 other carbon atoms. Only 3 outer electrons are used in the bonding. The 4th electron is remains delocalized, allowing graphite to conduct electricity. For these reasons, here 4th electron is remain delocalized. For these reasons, graphite can conduct electricity, but diamond cannot conduct electricity because all electrons are used for bonding. There is no delocalized electron. The atoms make a planar arrangement of hexagonal and plates and held together by weak intermolecular forces. Okay, the atoms make planar arrangement, like planar arrangement and planar arrangement. Another this planar hexagonal planar arrangement, hexagonal, like 1 2 3 4 5 6. If 5 electrons, 5 here, it will be pentagonal, but here is 6 1 2 4 5 6. This is hexagonal plates. and held together. This hexagonal plates and this hexagonal plates held together by weak intermolecular forces. Intermolecular forces. Okay, giant covalent networks. Giant covalent networks bonding is also found in boron and silicon compounds like silicon dioxide. Silicon dioxide has a covalent network structure. Its formula show the ratio of silicon and oxygen in the network is 1:2. So ratio of silicon and oxygen is 1:2. If silicon 1, oxygen will be 2. If silicon 50, oxygen will be 100. This 1:2. The formula of covalent networks show the ratio of atoms in the structure, not actual number of atoms. Okay, covalent properties, melting and boiling point. Covalent molecular substance have covalent molecular structure. It is a small molecule like water. They are not giant molecules. Okay, covalent molecular substance have low melting point, low boiling points. They need breaking weak intermolecular bonds between molecules. Okay, for these regions here they are low melting point, low boiling point, because we have to break only weak intermolecular bonds for boiling, for melting. Okay, if they overcome only weak intermolecular force, so we apply less amount of heat, so melting point and boiling points is low. But in giant covalent network substance like graphite diamonds, these are and silicon dioxide, they contain giant covalent network substance, have high melting points, high boiling points, because breaking strong covalent bonds between atoms. Here strong bonds need to break, and lot of strong covalent bonds. Here not fixed number, not atom number is not fixed. Huge number of atoms are joined together, so need to a lot of bonds, so need a lot of energy. So they have high melting point, high boiling points. তো ক্লাস শেষ হয়ে গেল নি? Okay, this intermolecular forces আস্তে ধরো কিতে হইলো। Okay, these molecules, simple molecular structure. Molecules contain fixed number of atoms joined together by strong covalent bond. If we look closely at liquid water, there are individual water molecules where the hydrogen oxygen atoms are joined together with strong covalent, but there must also some forces between water molecules which keep them in the liquid state. These forces are intermolecular forces. Okay, gaseous water molecules, liquid water molecules. There is no intermolecular forces between. There ami class ase. They are overcoming intermolecular forces. They become gas. Keu karo sate nai. Dekho, here they are close together because among the molecules there is the intermolecular forces. For this reason, these are remaining in liquid state. When substance consists of molecule with intermolecular forces of attraction between them, intermolecular forces, we say it has simple molecular structure. Example, simple molecular structures, compound which contain intermolecular forces. Like water contain intermolecular forces, carbon dioxide, methane, ammonia. This is, what is this? Ethene. Okay. Substance with simple molecular structure tend to be gaseous or liquids or solid with low melting points and boiling points. The reason for this that not much energy is required to break the weak intermolecular forces of attractions between molecules. Okay, for these reasons they have simple molecular structure containing compounds have low melting points, boiling points, because the reason for this is that not much energy is required to break the weak intermolecular forces of attraction between molecules. Okay, melting point. Yeah. Look, melting point and boiling point. This compound. What is this? Group 7 elements. These halogens, sir. They are diatomic molecules. Look, diatomic molecule with intermolecular. They contain. They are simple molecular structure because they contain weak intermolecular forces between them. Look at their boiling points. Fluorine F2, F2, chlorine FCl2, bromine Br2, iodine I2. Look, relative atomic molecular mass. Fluorine 38, chlorine 71, bromine 160, 254. Look, melting point fluorine minus 220 degrees Celsius, boiling point minus 180, chlorine minus 101, bromine chlorine melting point boiling point minus 34. This is minus. This bromine minus 7, boiling point 59, iodine 114 melting point and boiling point 184. So they have melting point and boiling points. Look at melting point and boiling point increase with relative molecular mass increases. Look, melting point minus 22, minus 101, minus 7, minus 114. Here relative molecular masses increases. With increasing relative molecular masses, melting points and boiling points increase as the relative molecular mass increases. Do you know how to draw this one? How to draw this diamond structure? Giant covalent structure. Now I am not finished this covalent molecular compounds. Okay, covalent molecular compounds have low melting points, low boiling points. We have just seen. Now they have another properties. No, there is many properties. One properties I have thought. Okay. Some other physical properties of covalent compounds. Covalent molecular compound don't conduct electricity. This is because 10 minutes. This is because the molecules don't have any overall electrical charge. They have no charge plus minus, or they have no remaining electrons. This is because the molecules don't have any overall electrical charge or plus minus charge, cation or anion, positive charge or negative charge. All the electrons are held tightly in the atoms or in covalent bonds. There is no remaining electrons, so are not able to move from the molecules to molecules. For this reason, they don't conduct electricity. Simple molecular compounds don't conduct electricity. Okay, they have another properties. Covalent molecular substance tend to be insoluble in water. They are insoluble in water. If you covalent molecular substance containing water, you dissolve in water, they will remain insoluble. Insoluble will be. Like solubility, soluble means if you dissolve sugar in water, shaking, you find clear solution. This is dissolved, soluble. If you dissolve clay in water, you find turbidity or cloudy. This is insoluble. Okay, covalent molecular substances tend to be insoluble in water. There are some exceptions to this. Okay, there is some exception. Ethanol is covalent molecular compound, but it is dissolved in water, soluble. And substances such as ammonia and hydrochloric acid react with water as they dissolve. This one also dissolves in water. And other organic substances, covalent molecular substances are often soluble in organic solvents. Often, अच्छा. Covalent molecular substances are often soluble in organic solvent. Organic solvent like organic compounds. Organic compound, methane, ethane, the carbon tetrachloride, they are organic solvents. So covalent molecular substances are dissolved in organic solvents. Often, frequently. Now we have learned properties. There melting point, boiling points, electricity contact. They don't contact electricity. They have low melting point, boiling point. Molecular substances tend to be insoluble in water, but there is some exception for ethanol and ammonia and HCl. And covalent structures, diamond like look this diamond. Each carbon has 4 electrons in the outer shell of we know carbon as outermost shell is 8 electrons. Carbon 6 electron. Carbon 1 is to 2 4 okay, 2 4, this 6 electron in the outer shell, carbon. So we can draw this 6 electron this way. 1 carbon atoms, there is a 4 carbon atoms. This is 1 electrons, 2 electrons, 3 4, another carbon atoms, 4 electrons. কিতারে একটু যায় না কেন? লাইক দেখো এখানে একটা আছে, দাও আরেকটা দাও এখানে দেই, এটার সাথে দেব, এটার সাথে দেই, এটার সাথে দিলে একটা জায়গা হবে, এটার সাথে আরো দেই, 4টা দিয়ে দেই, একটু ছোট করে দিয়ে দিই, এটার সাথে আরো 4টা। এই প্রথমে আঁকলাম, ধরো মনে করো এইটা আঁকলাম, এইখানে আঁকলাম, এটার কয়টা হবে? 4টা হবে। হ্যাঁ, 4টা কার্বন অ্যাটমস। তো আরেকটা কিন্তু ওটার সাথে ওটা জয়েন্ট হয়ে যাবে একটা, আবার এটার সাথে। এটা আমার এখানে আঁকা হয় নাই কিন্তু, বারবার এখানে হবে 4টা, এই 4টা হবে। তো আর একটা কার্বন যেন এখান থেকে একটা আসলো, এটা এইটা আবার আর একটা কার্বন অ্যাটম, কার্বন অ্যাটমে 4টা আছে, 4টার মধ্যে একটা ওটার সাথে জয়েন্ট হয়েছে, আর ওটার আর একটা ওটার সাথে জয়েন্ট হয়েছে। একটা কিন্তু অনেক লম্বা আছে, এটার সাথে ওইটার সাথে জয়েন্ট হয়েছে। হ্যাঁ, এটা ধরো এখানে ওই রকম স্ট্রাকচারটা হয়েছে, তোমরা দেখিয়ে আঁকিও। মানে এখানে 4টা ইলেকট্রন, কিন্তু ওই যে কোনো ভাবে এইটার সাথে এই ইলেকট্রনের সাথে আবার ওইখানে আবার কার্বন আছে, আর একটা কার্বন অ্যাটমের 4টা হাত আছে, মানে ওইটার সাথে জয়েন্ট হয়েছে, ওটার সাথে এটা জয়েন্ট হয়েছে, মানে কোনোটাও কিন্তু ব্যাকএন্ড নাই। এটার 4টা ইলেকট্রন, এটার এটার ওটার কিন্তু এটার দেখো 4টা ইলেকট্রন এখানে ইউজ হয়েছে, আর একটা কার্বন অ্যাটমের 4টার একটার সাথে জয়েন্ট হয়েছে। এটারও এই যে একটা আর একটা কার্বন অ্যাটম 4টার মধ্যে একটা জয়েন্ট হয়েছে। আবার ওইটার আবার চারটা ওইটার সাথে জয়েন্ট হয়েছে, ওইটার সাথে জয়েন্ট হয়েছে, মানে কোনোটাও কোনো একটা ইলেকট্রন তো ব্যাক এন্ড নাই। আচ্ছা, in diamond each carbon bonds to 4 other carbon atoms in a tetrahedral arrangement. This arrangement is tetrahedral arrangement. Okay, okay, like if you draw this way, this is the linear arrangement. This arrangement is tetrahedral arrangement. Like this arrangement is trigonal arrangement. This linear arrangement, trigonal arrangement, and this arrangement is tetrahedral arrangement. Kita এখানে গেল শেষ হইল গ্রাফাইট ডায়মন্ডটা দেখলাম diamond has very high melting point, boiling point, because this is because of the very strong carbon-carbon covalent bond which extend throughout the whole crystal in 3 dimension. A lot of energy has to be supplied to break this strong covalent bond. Therefore diamond has very high melting point and boiling point. It is important to realize how this is different from the simple molecular structure that we saw above in order to melt and boil in a substance. With simple molecular substance such as methane, we only had supply energy to break relatively weak intermolecular forces force of attraction for simple molecular. In diamonds there is no intermolecular forces. It has giant structure. There are no molecules, covalent bonds which are very strong. Okay, there are no molecules in graphite diamond. Covalent bonds which are very strong must be broken in order to melt and boil it. So they contain strong covalent bonds. If molecular structure containing compound like water, they need to, if we want to break this element, you need to only break weak intermolecular forces. For this reason they have low melting point, boiling point molecular compound. But giant compounds like graphite, they contain very strong covalent bonds, must be broken in order to melt and boil it. In general, all substances with giant covalent substance structure are solids. Oh, okay. All substances with giant covalent structure are solids. We have seen in molecular structure, there's maybe liquid, solid, even gaseous. All gaseous, liquid substance, gaseous substances are contained in weak intermolecular forces. For this reason they have low melting point, high boiling point. They are giant covalent structure containing compounds are solids with high melting point, boiling point, because a lot of energy has to be supplied to break all strong covalent bonds throughout the giant structure. Other substances with giant covalent structure include graphite and silicon dioxide. Okay, giant molecular structure containing compounds, giant covalent structure, are solid with high melting and boiling points, because a lot of energy has to be supplied to break all strong covalent bonds throughout the giant structure. A lot of bond need to break throughout the structures. For these reasons they have high melting point and boiling points. Diamond is very hard. Again, a lot of energy has to be supplied to break strong covalent bonds in the giant structure. Drills beads can be tipped with diamond for drills used on stone and rock. Diamond doesn't conduct electricity. All the electrons in the outer shell of the carbon atoms are tightly held in a covalent bonds between the atoms. None are free to move around. Diamond don't conduct electricity because there is no delocalized electron. All electrons in carbon atoms are joined together by bonds. Now graphite. Graphite, look, pencil ink is graphite. Graphite is soft with layer. Diamond is hard, we have seen. Graphite also form of carbon. This is the allotropy of carbon. Graphite is also form of carbon, but atoms are arranged differently. Although it still has a giant structure, graphite has a layered structure rather than a pack of playing cards. In pack of cards, each card is strong, but individual cards are usually separated. Two plates, we have seen hexagonal plates. They are separated by separated. This same is true in graphite. Okay. Atoms in layer of graphite. This look one carbon atoms joined. These four hands in a carbon atom, 4 electrons. This here one carbon atoms joined 1, 2, 3. Here 1 electrons is remaining. And this carbon joined together another carbon atom. This one joined this one, previously one, new one, and this one also joined together previously one and new one. This way they form hexagonal layer. This is hexagonal layer. There is a layer by layer. Okay, edge on view of the layer. Okay, this is one layer, this layer, one layer. This is one layer. Like this is second layer. This there is layer. So among the layer, forces of attraction between the layers. Look, this is hexagonal layer. This is a force of attraction between layers. Have you seen? The gaps between the layers are much bigger than the distance between the atoms in the layers. Okay, now check it. Two topics की बात पड़ेगा. এখন আসছে একটা diamond and graphite are allotropies of carbon. Allotropies are different form of the same element. Okay, another allotropies are different forms of same element. Another allotropies of carbon is carbon 60, fullerene. This is allotropy of carbon. Carbon 60, fullerene. Diamond and graphite both have giant structure, but fullerene has a simple molecular structure. Okay, in solid or liquid, carbon 60, fullerene, there are carbon 60 molecule with weak intermolecular forces between them. The fact that carbon 60 has a simple molecular structure has a big influence on its physical properties. Carbon 60 fullerene has lower melting and boiling points than diamond and graphite. When fullerene is melted, fullerene. When fullerene is melted, only relatively weak intermolecular forces of attraction must be broken. Only you break weak intermolecular forces of attraction must be broken. This does not require much energy as breaking all strong covalent bonds when diamond and graphite are melted. Okay, fullerene. Fullerene is not as hard as diamond. It does not take as much energy to break the intermolecular forces of attraction. Okay, to break intermolecular force of attraction in fullerene, carbon 60 fullerene don't take much energy compared to breaking strong covalent bonds in diamond. Fullerene does not conduct electricity. Although all the carbon atoms in fullerenes only form 3 bonds. এখানে তো 3 bonds বললো, তো আরেকটা bonds রইবে কার্বনে. The fourth electron on each atom can only move around within each fullerene molecules. The electron cannot jump from molecule to molecules. Okay, it is formation is like graphite. Carbon atoms can form 3 bonds, so one remaining fourth electron is remaining vacant, but this fourth electron on each atom can only move around within each molecule. একটা মলিকুলের ভিতরে কি করে মুভ করে, সে আরেকটা মলিকুলের আরেকটা ফুলারিন মলিকুলের মধ্যে কি করে না, যায় না. For this reasons the electron cannot jump from molecule to molecules. For this reason fullerenes does not conduct electricity. যেটা ইলেকট্রন একটা ফিরে আসে আনে, ইলেকট্রনটা শুধু একটা মলিকুলের মধ্যেও থাকে, আরেকটা মলিকুলের মধ্যে কি করে না, ইলেকট্রনটা জাম্প করে না. ওকে, শেষ চ্যাপ্টার. থ্যাংক ইউ ফর জয়েনিং টুডেস ক্লাস. আই উইল গিভ অ্যাসাইনমেন্ট. You must assignment complete by 27th August, and then we first online exam will be held. Topics on bonding chapter 7, 8, 9 on 31st August at 12 p.m. Thank you for joining today's class.